first patch I'll be demonstrating today is called Altera. It's a compositional performance that utilizes FM synthesis, effects units, and voice phasing. So the controller mappings that I've used, it uses a DualShock 4 PS4 remote mapped to max MSP to control the patch, and in this diagram you can see all of the different controls. I'll be showing some of them in action here. So to start, you go into GUI interface, which has all the different controls for the patch. So basically, to start playing around with this patch, you need to first select from a list of melodic sequences that are randomly, stochastically chosen from the sets lists. So group 1 of the sequences is here, group 2 of the sequences is there, group 3 is there, and group 4 is there. Now, from these 8 sequences, you can choose them by hitting either the X button. So the first group is here. I'm going to try selecting from that. So that has activated a selection from this group, and to start the patch, all I have to do is press the PS on button on the DualShock 4. So that's phasing at the moment, so I can take that off phase by using the D-pad. I'll just stop it again. So you can select from different sequences. If I choose another one using the circle button and press it on, so you can select, each time you press the same button, you can select through various ones of these sequences. You can also change the timbre of the instrument by selecting from an algorithm. So if I press play, so what's happening here is it's choosing a different FM algorithm for the oscillator, and that changes the timbre slightly. And if I move these controls, that affects the oscillator depth. I need to switch the FM to between series and parallel for that to work. So that you can create some pretty cool sounds with that. If I change the sequence again, I'll choose from a different voice phase. There's basically two identical voices playing, so you can create a melodic offset or rhythmic offset, and that creates some nice harmonies because you're playing a sequence that's written in the same key in two different phase locations. You can also use low cut frequency, which is triggered by the DualShock 4 bumpers. You can also activate flanger, which is used by selecting the depth and speed controls. Can be done by clicking the DualShock 4 touchpad. So the y-axis is used to change the depth of the flanger speed, and clicking the touchpad to switch to depth, the x-axis is used to control the depth of the flanger depth. So at 0, that's none. Finally, one last control is the octave function, which is done by it's located here, and you can cycle through that by pressing either options or share. So if I wanted to transpose it down an octave, I do it there. Just switch between another algorithm. So it's a fairly experimental patch, but all of the effects can be controlled via the DualShock 4, and the abstractions for that can be found under HID mapping, human interface device mapping, and that's all converted from an HID input into MIDI signals, which are then routed to different areas of the patch. Thank you. Okay, so the next patch I'll be going through is called Potentia Machina, which is a composition engine that uses Markov chain probability theory to procedurally generate unique melodic and rhythmic sequences. So the way that Markov chain theory works is that you have a set list of numbers. Here's an example: 1, 2, 3, 4, 5. Each with a list of what's called transition probabilities associated with them. So these can, not necessarily have to, but they can change from number to number, and it's used for changes to the likelihood of progression to various numbers in this list. So if when you're on 1, the chances of progressing to 2 could be 10%, or 3 could be 3 could be 50%, or 4 could be 0%. And then when you, for instance, if say it lands on 2, and you end up on 2, the chances of progressing to other numbers in the sequence could change, and that's the general idea. So it's a very fluid type of stochastic theory. So the patch uses this technique to select stochastically from a programmable list of intervals in order to build a melodic sequence. So in the GUI here, this window here is a display of a generated sequence. So if I start it here, you'll be able to it will refresh this list of numbers here, and you'll be able to hear each one of these is a musical interval within a scale, an octatonic scale, or heptatonic scale, sorry. So if I press play here, now you see that changed there, because what you have here is the project's sections, and these are calculated each time you press play in the GUI controls. So if we go into abstractions here, this is the workings of the patch. You can see transition probabilities here, and what happens is at the end of each sequence, it instantly calculates and generates a brand new sequence just before it starts playing that sequence. So each one of these represents the transition probabilities for each individual interval in a heptatonic scale with a root octave note for the 8th note. That would be octave above the root. So that's also informed by determinate section-based changes to key signature and octave, and the mode as well. So you have different modes here, and so that's not the changes to the octave, key, and mode are determinate. They're not used. They're not affected by the Markov chain system, which is over here. So the the lengths of each section are calculated stochastically when you start the patch. So if I press start here, that changed from a 3 to 4. So there is a general sort of range for the. It goes from about 2 to 4 for 2 to 4 bars for each section, and if it'll loop the sequence for so the first section is 4 here, so it will loop this bar for 4 bars, and then it will change to a new section which will loop for another 2 bars, and then it will change to a new section. Now these first 2 sections are associated with the same interval transition probabilities and key signatures and modes. So what you get essentially, it's a demonstration of 2 iterations of 2 generations of sequences using the same data, and then you move on to a new set of data, so a new set of interval transition probabilities, new key signature, and a new mode, or not necessarily a new mode, but there's new things that occur after every 2 bars. So you get the two generations within each 2 sections, and then another 2, and then another 2, and then another 2. So I'll give you a demonstration here. So that gives you a sort of idea of how the compositional engine generates a sort of a overarching type of form throughout the composition. So one last thing I'd like to mention is the way in which the patch assigns durations. So what we have here is the abstraction for duration assignment to each scale degree in a sequence. So the way in which it does this is it has a list of duration values, which are also they also are associated with sections and changes to sections. So they're actually associated with interval transition probabilities, which are obviously associated with the sections. So what we have here is a list of duration values for the 8 notes in a sequence, and these are in milliseconds. So that's half a second, that's 1 second, that's half a second, that's 2 seconds, that's 1.5 seconds. And the way these are the way these are assigned is if you go into assign durations. So it says of the durations sent from subpatch duration values, in order from left to right, the first values will be assigned to the lowest numbered notes in the sequence, then the second lowest numbered notes will be applied, and so on. So using a duration list of 500, 500, 1000, 1000, 500, 1000, 2, well, you get the idea. So you can reprogram the duration values. You can also reprogram the interval transition probabilities. You can also reprogram the key and octave transposition and the modes. It's all reprogrammable, but I've set it up for demonstration of what it can do. So if I give you an idea, if I start it playing, after a little while you'll be able to see these duration values change. So it's using the same duration values for the second section. And one of the duration values changed there. Now the reason why these are a different set of, they're being assigned here, and these are assigned just before, at the same time as the sequences. Just after the sequence is generated, before the next bar. These are then immediately after assigned. These values are then immediately assigned to those intervals of the sequence, and this all happens in a fraction of a second before the next sequence is played. So that's essentially the general workings of this patch, and it's quite simple at the moment because it only has a piano sound. But if you can imagine, this can be applied to a string, a violin or a cello or anything, or a synth instrument, and it is very. I mean, the actual workings of the patch is very complex, but the effect you get is quite basic. But building on this, you could make it something quite convincing if you were to spend a lot of time deciding which interval transition probabilities to use, which keys to use, that sort of thing. You could also potentially do some things with velocity and dynamics and that sort of thing. So it really can go a lot deeper than this, but the reason why I created this was to further my knowledge, broaden my knowledge in procedural generation, and do something towards starting work in the video game industry that involves generative composition, because I think this could actually be the sort of thing that modern games could adopt. Thank you very much.